everyone, welcome back to yet another video in Java programming series in 2025, and today we'll be talking about arrays in Java. So far we have been dealing with single variable. For example, if we want to represent something, we always have been dealing with single variable. So as of now, so we have, let's say, if we have a class that represents like many students. For example, I have a string name John Doe, but if I want another student called David and another student called Smith, right? What we have to do is we have to create such multiple variables, and with array we can avoid this limitation. So basically, we can store multiple variables under the same name. For example, let's say call it names using arrays. All right, so let's go ahead and see what exactly arrays are. For example, an array is a container object that holds a fixed number of values of a single type. So basically, array allows us to store same type of variable. So people call it like same type of values or homogeneous values under the same name, and then we can specify how many elements we want to store. So this length of the array has to be fixed, right? If we want to increase or decrease, there is a manual effort, and but when we create, we must give it a size, and the length of the array is established when the array is created. So like I said right now, so we have to specify the size or the length, and that is going to be the array length, and we have to create or specify. So when we create an array, right, so that means like the array length is fixed. We can change it, but we have to manually do the all the logic. All right. So here is a diagram at the official documentation. So for example, the first index, it is always going to be 0, and the last index is going to be the length minus 1, because the array index always starts at 0. The last index is always going to be the total length. For example, here the length is 10, and the last index is going to be 9, right? Because it has started at 0. And the one of the important things is, even though we can store different types of data, I mean, we have different types of array. For example, we can have integer array, we can have double array, we can have string array, etc. The index is always going to be an integer value. So even if you store string value here, so the index is always going to be, because it's essentially a location of the value, right? So whenever we create an array, the memory location is going to be contiguous. For example, the first memory address is always going to be decided by operating system. We cannot control where to store. I want this memory location, but after that it is going to be +1, right? That means it is going to be next, and this is also going to be next to this, and so on, right? The first is always decided by operating system in coordination with JVM asks, hey, I want this block of memories, please provide me, and then operating system allocates, and those addresses will be contiguous, right? That's one of the important things to notice. And otherwise, so we can have, like I said, integer array. When we want to create something, we will have this square bracket representing array. So if we omit this is going to be single variable, but if we write this square bracket, this is going to be an array symbol. And here we have provided the length. That means I want an array to hold 10 data, right? I mean, I can leave it unused, but I must specify an some variable or some value that can basically tell Java that, okay, I want this number of elements. All right, and then, so like I said, we are going to access the element by index. So if I want to put 100 in 0th position, so we can do it. So array and then 0 and then equals to some value. So if it is like integer, we can only place integer value, right? Because this is integer. Now let's go ahead and create a brand new file and we will see operation with the help of code. All right, let me close this one and I'll be creating a new file called compact file array and then demo. So if we want to create an array in Java, like we saw earlier, so we have to specify data data type and then array symbol, right? You can also not have a space here, that's perfectly fine. And variable name, and this is like array declaration. And if you want to like also initialize at the same time, give some size, you can do data type and then variable name equals new, and then again data type and then array and here size, right? So how many number of elements you want, or you can say length, because this size is like understood differently when you move to other data structures like array list. So now here you can say length, right? So basically we can create, let's say, let's imagine that we want to store IDs of all the students in a classroom. What we can do is we can do say, well, I want integer array, that means array, and then IDs, and then, or we can say student IDs. All right. And what we can say is we can also leave it like this and initialize later. But if we want to initialize it once, we can say integer and then array. And I can write a semicolon and then specify the size. For example, imagine there are like 10 students in a classroom. So what I can say is just give me 10 blocks, right? That means now I can access the properties of this array. For example, one of the properties is length, and this is also going to be integer, always integer. Length equals to student IDs dot length, sorry, dot length. And now if I print length, it is going to be 10, right? Because we have specified this value. So this is going to be 10, the length is going to be 10, right? But now, since we have created integer array and we haven't explicitly provided value, we can also access the elements in this array. For example, I can print as out and then student IDs of and then 0, right? That means, okay, give me the first element. Let's see what has been filled. Look at this, 0, right? So since this integer value, this is going to be initialized with integer default value. So even if you don't assign any value, you have to make sure that you have to be aware that this 0 will be here because it's integer. If it is double, it is going to be 0, 0.0. If it is string, it is going to be null, right? So now, basically, if you want to assign something new, for example, student IDs, let's say student IDs of 0, first ID is 1, 2, 3, 4, 5. Okay. And now if you just print this value again, it is going to be this 1, 2, 3, 4, 5. Now, because we have assigned a different value. And if you similarly, if you want another value to be assigned, for example, for 1, 2, 3, 4, 5, 6, and also, let's say, in a similar way, if you want to assign a last value, for example, since last value is going to be like length minus 1, so what we can do is length minus 1 because index always starts with 0, and then it is going to be, let's say, 9999, right? And then now if I do s out student IDs of length minus 1 and print it, this is going to be 9999. Well, you might be wondering why we are keeping minus 1. Doesn't this work? Yeah, like I said, because it always starts with 0. And if you attempt to access something that is not in the range because there doesn't exist any value, student IDs of 10, it is essentially saying 10, right? Now we will get index out of bounds exception, right? That means index, look at this error, index 10 out of bounds for length 10. That means the length is 10 and you are trying to access 10, which is out of bounds, because the array index always starts with 0. So it can never be more than len minus 1, right? We have to make sure that we are not accessing element that is not in the range of the current array, right? So it should be len minus 1, and this will perfectly work. All right. So, and similarly, we can also create not only integer. For example, let's say we want to store some names, like the same again, student names, for example, string, and then student, and then names equals to new string. And what I want to say is I also want to store 10 names, or let's say just store 3 names or 5 names. Okay, it is the same. For example, if I print the length just like this, it is going to be 5, right? And so if you want to insert something, again, student names, sorry, student names of 0 first name, and again it's going to be John Doe. And if I want to store another name, let's say 1, and if I say David, and I want to store the last name, Len, sorry. So what I can do is student names dot length. It is going to give us like the length and then minus 1. Last element is going to be let's say Smith. Okay, so if I print as out and then student names of, let's say now 9, we have, sorry, it is no 9, it should be 4, right? And if I print, it should give us Smith. Okay, so but if I print, let's say student names, it is always going to give us a memory address, right? This, the reference to this, right? Because this is now referring to some location. And if we want to print, we have already studied, so we can do is just use for loop. So for, and then integer I equals 0, I less than student names dot length. I'm going to be names.length, but here it should be names.length because we are just considering less than. If it is equal to, we have to do minus 1, and then I plus plus. Now it is like, it is going to be 0, 1, 2, 3, and 4. And then if I do, and so for example, name it, and then ith index is going to be, all right, and then student names of I. Now this is more dynamic, and it will print all the student names given in this array, right? And look at these other values, they are null because it is a string, and then the default value for a string is null, right? So one of the things in arrays is, you cannot know how many, real values we have, because it is always going to be, there is no some property like size. We only have a length, and length refers to how many element we intended to use when we were defining this, or how many elements we defined this array to have, right? So here, so if you want to insert, okay, I want to track how many real elements are there, you have to make your one logic, like, every time you insert, or every time you write something, increase your value and then increment the value, and then do the operation as per your need. So this is like pretty useful when there are fixed elements you want to store. Otherwise this array is especially not a good choice, because imagine now you want to make the size of this array to let's say 10, right? For example, you might say, well, I can do student names and then equals to new and then a string, and then if you do 10 and print it, now look at this, everything is null. This is why, because now you have completely reassigned this array with a brand new location. That means it only has a default value of a string which is null, right? So this shifting, you have to do shifting and all. So if you want to redefine it, and then you what you have to do is you have to make sure that you first copy the existing value to new array and then increase the size of the array, and then you have to add the new element to the modified array, right? So of course we have a couple of methods there. For example, one of the methods, let me see, uh, arrays dot copy of sorry, original student names, and then new length is going to be 10. And then if I do it, let me string and then new names, right? So this is new names, and if I print the same thing using another for loop, right? And so the same thing, new names dot length, and never read. Okay, sorry. Here it has to be new names. And if I print it, look at the last 10 elements. All right, so no, because it was already modified. So I'm gonna be commenting this out, this one as well. As of now, as of now, we have three names, and this array should have three names and other default. Now size should be like 10, three names, and then the seven default values. Look at this, John Doe and David, and then Smith, and rest of the values are. So now what we have done is basically, we are just using the built-in method from arrays from Java API itself, right? It's a copy of it. Essentially does the same thing that we discussed earlier, but we don't need to worry about this, right? So the overhead of shifting an array is real, and especially not a suitable data structure to consider when you have dynamic number of elements. It is pretty useful when there are fixed number of elements, because the accessing element is pretty fast. And so why we can access pretty fast is the memory locations are contiguous, like we discussed earlier. And if I want to index, because I always know the first, these names, first element, sorry, first memory address of this array variable. So if I want to address or access some index value, it will be calculated based on that first array. And since it is going to be contiguous, we can just, let's say if it is first array address is 10, and then I want to access second element from this is going to be 11, right? Because the first is going to be 10, right? On a similar fashion, the Java can calculate and provide us the exact value for that index if it exists. Otherwise, it will throw index out of bounds exception, right? And we'll be handling those exception in future. So that was pretty much it. And one of the things, even though we have said, for example, here, if I try to insert, let's say, here name, if I try to give, for example, 1, it is not going to be valid, right? Because now it is integer. But what we have told the compiler is, okay, we'll be storing only string array, right? So what we can do is, this is definitely not recommended approach, but what we can do is, since in Java everything is a subclass of object class, what we can do is object array, and then, for example, different types equals to new object, and I'm gonna say 10. All right, now since this is object type, I can insert anything here. Div types of 0, it is going to be 1, and then div types of 1, it is going to be like 11.11. This is double and this works fine. And if it is, let's say, 2, and then I can even string like mango. Look at this, I can store every type of variable, and if I print it, this will be valid as well. Okay, so different types, and then if I print it, it's going to be valid actually, because now yes, look at this. Here we have 11.11 and then mango, right? This is because this is definitely not recommended, because a runtime, if you have different types of data, you have to do a lot of casting and things like that. The best practice is that, but you can keep in mind that if you somehow need to store different types of data, you can do so by using object, but be careful with this. But from learning point of view, it is one of the things that you can keep in mind. I'm sorry, I missed the one of the ways to initialize. The another way to initialize data, when you already know that I will have only this and this values in array. For example, let's say you already know that there is a certain age is going to be there. So integer and then age is equals to, if you already know that you will only have 10 and then 20 and 30, this is how you can access this, because if you do like this, now age is already predefined. That means the compiler knows that it's an array of length 3, right? So if you try to access 0, it will be accessed. And also you can keep optionally this one, but that's not even required, right? You can do this one, or you can omit this array syntax as well. I mean, a square bracket, and the compiler will automatically understand, and everything else is same. I just wanted to also point this out, because this is like one of the useful ways when elements in advance, right? um, so that was pretty much it for this topic. I hope you understood something from this one. So try creating other array variables, and then also try to access elements and do some manipulation, and you will understand more. If you have any questions, please let me know, and I will see you on the next one. Thanks for watching.